Welcome, friends. Today we shall start our new chapter, which is underground cable. Underground cable is another way of transmission and distribution of electrical power. So it is an alternative to the overhead system. Okay, it is an alternative to the overhead system. So we shall go one by one into the details of this underground cable chapter. So let's proceed. As underground cable, as the name suggests, underground cable it is a transmission system or distribution system below the ground. Okay, so the cable is laid or the conductor is laid below the ground. So as already I told you that it is an alternative way. It is an alternative way of transmission and distribution of power. As it is laid below the soil, below the ground, so it is not exposed to the atmosphere, so it is advantageous for us, because as it is not exposed to the atmosphere, so it is free from any adversity, free from any weather adversity. Free from any weather adversity. However, this system is extremely expensive. This is the drawback of our, as far as the economic consideration, economic point of view, and it is aesthetically beautiful as it is laid underground the cable, so nothing is exposed to the atmosphere. So the junk of the wires, which is very normal to see in our locality, is not observable. Okay, so it is, underground cable is always aesthetically beautiful. Now moving to our next slide. Now, as the construction part, in the construction, we have underground cables. We have several layers. Now, this first layer, this is the layer. This is called conductor. It is the current carrying part. Okay, this is the current carrying part. Now, through this conductor, we have a conductor screen. We have a conductor screen, or you can say it is a paper insulation. Now, next, coming to the second layer, this is the insulation screen, or it is called insulation. Okay, it is provided to insulate the conducting path. This is the second part, and this is the first part, standard conductor. Now, beside these two, conducting part and insulation part, we have several other layers as well to protect mainly underground cable from mechanical injury and from some chemical impurities. And like, say, we have a third layer, this layer that is called metallic sheath, this third layer. Okay, this is the third layer. We have metallic sheath. It is made up of lead. It is made up of lead, mainly provided to protect the core, that is, protect from the conductor from moistures and other chemicals, like water vapor, maybe, or some chemicals dissolved in soil. Okay, so that lead sheath is mainly provided to protect our conducting part from the moistures. Now, over lead sheath, we have another layer. It's called bedding. Now, it is mainly provided to protect the lead sheath from corrosion and erosion. Okay, as it goes below the sea level, so it goes through various corrosion and erosion process with the soil. So this bedding is provided, or bedding is provided to maintain, to safeguard metallic sheath from the corrosion and erosion. We have two more layers. Armoring, this is our fifth layer, armoring, and we have last layer, it's called serving. These two layers are provided to protect the cable from mechanical injury, to protect our cable from mechanical injury. Now moving next, we have what advantage we should get from the underground cable. As I already told you, it is not exposed to the ground, so it is not exposed to the ground, so it is free from lightning effect and any kind of adverse weather condition. So it is definitely advantageous for us. Now this is very important. We have underground cable. Have very low L value, this is the very important feature of underground cable. We have L is extremely low. However, but capacitance is extremely important. So L is very low. However, capacitance is very significant. If you compare with this underground cable to the overhead system, overhead line, now in case of overhead line, capacitance and inductance are both important. However, in case of underground cable, capacitance is very much significant. However, L is not that much of significant because of its low value. Why? The reason being, as you know, the fundamental formula of L is directly proportional to Ln dm by ds or d by r, whatever you can say. Now, as the underground cable, if you contrast between the two systems, if you compare the distance between any two conductors, it is in the dimension is in the meters, probably. Okay, in all probability, the difference or the distance between any two conductors is in the range of meter. However, in case of an underground cable, this is in case of overhead system, overhead line. However, in case of an underground cable, the distance between two conductors probably is in the range of millimeter. So you see, this dm will be extremely small. In all probability, it will be 1000 times less. Okay. So inductance value will also be very small. So this is the reason for underground cable, the value of L is extremely low. So we should not give much attention in calculation of L. So as L is very low, so from L we have omega L, that is inductive reactance. So that omega L into I, that is inductive reactance or voltage drop, that is also low. So that is the advantage of underground cable. So voltage drop is less in case of underground cable. Now moving on to the next point, as it is passing below the soil, it is expected that it is free from the interference of the communication telephonic line. Moving to the fourth point, as it is not exposed to the atmosphere, the maintenance cost is expected to be very low. Hardly any fault or hardly any maintenance required. And last point, it is aesthetically very much beautiful as it is not exposed physically as well as visually to the nature. These are few advantages of underground cable. Now, the other side of the coin is the disadvantages. As I already told you, it is extremely expensive. It is extremely expensive because of the structure of the cable. Because of the structure of the cable, if you compare the overhead system, if you compare with the overhead system is only one conductor. Overhead system is only one conductor, but underground cable, you require conductor. With that, you require 5 additional layers in order to protect the core and several things. So, you know, the costing is extremely important. So, it is very expensive system. Also, as the voltage level increases, cost of insulation also increases. Now, as it is takes large value of C, or it is a very significant value of C, it takes large charging current. It takes large charging current, which is equal to V by omega C into V. This is the formula for charging current. It takes large value of charging current. Now, as it is go below the soil, or below the ground, it is expected that no disturbance occur throughout this length of this cable. Okay, it is expected that. However, due to any reason, if some fault comes or if any disturbance comes at any point, okay, so that becomes extremely difficult to locate and repair. Okay, that becomes extremely difficult to locate and repair the fault. As long as it is going below the soil, it is extremely good. 99.99% of time it is running extremely smoothly. However, unfortunately, if some fault comes at any point of length or at any point of time, it becomes extremely difficult to locate and repair. Now, if you want to repair, you need to dig that soil. So it is a loss of resources, loss of money, everything. Another point can be said that expansion of new loads is not possible. So let us say today my load is 100 ampere. Now if it needs to increase by 50% to 150 ampere, so with the existing cable configuration it is not possible. You need to erect a new line for it. You need to erect, or one need to erect a new line for the extended load. As now moving on to the last point, as listed, due to the economic reason, as it is extremely expensive, power can be transmitted or distributed. Okay, this is the medium of, or this is the mode of transportation or distribution of power, but within a short range of distance, maybe 10 to 20 kilometer, not more than that. Because as the length of the transmission of power and distribution power increases, as the length of the transmission and distribution power increases, the length of the cable, physical cable length will be increasing, so cost will be increasing. So due to the economic reason, it is not advisable to use underground cable over a long distance transmission and distribution of power. These are the few disadvantages of underground cables. Now, as it can be seen, moving on to, before going into the much details into the insulation resistance or further topics, as I told you, or it can be seen, the underground cable has several structures or several layers. First we have core, then we have insulation, or we can say it is a sheath insulation. Then we have a armoring, fourth layer was bedding, did I miss anything? Let me check. Conductor, insulation, third layer is the sheath. Sorry, third layer is the sheath, metal sheath or lead sheath. Metal sheath or lead sheath. It is metal used lead. Now fourth layer would be armoring, fifth layer would be bedding, and sixth will be serving. So several layers are there. And now to analyze the underground cable electrically, these layers, this 3, 4, 5, 6, these layers are not important at all. You can, to analyze the underground cable electrically, you should not consider these four: metal sheath, armoring, bedding and serving. You should not consider these four. So one should consider only core and sheath insulation. One should consider core and sheath insulation. How they are geometrically formed? Core is the central conductor having radius r. Core is the central conductor having radius r, and sheath is another circular shape. It is a insulating material with a dielectric medium epsilon r, having radius or diameter whatever say d. The live voltage or line voltage is impressed on the conductor V, and this is expected to be grounded. The sheath insulation is expected to be grounded. So if you want to analyze the underground cable electrically, it will be your overall structure. So we have a central conductor having radius r. Then we have a sheath insulation having radius d. Line voltage is impressed on conductor, and we have a dielectric medium having relative permittivity of epsilon r. Now in such a cable, insulation resistance is a very important issue, and it is formulated by this formula. Insulation resistance of underground cable is this. What is this? Rho is the resistivity. Resistivity of the medium. L is the length, and dr I have already told you what is d and r. Now what is insulation resistance? Now as the current should flow through the conductor in serial direction, some small amount of current flowing through these radial directions. These are called leakage currents. So these leakage currents are due to a leakage resistance. So that is called insulation resistance or leakage resistance. Now how it can be proved? So let us derive quickly. So let us say we have a conductor of radius r. We have also a insulating material of radius d. Now in between we assume a shell. We assume a shell. Okay. We assume a shell of thickness dx. We assume a shell of thickness so this distance is dx. So the current flowing through this path is, let us say, di, the leakage current. So due to this leakage current di, a small resistance dr will be formed, and that is equal to rho into dx by 2 pi x into L. What is x? X is the radius of this length. So this should be the formula. Now if you integrate, what will be the total resistance? What will be the total resistance? R. It should be integrated rho by 2 pi L integration. Now x varies from small r to capital D dx by x. So it will be rho by 2 pi L ln d by r. So this is called insulation resistance of the underground cable. So as it can be seen that insulation resistance of the underground cable is inversely proportional to the length of the cable. So as the length increases, insulation resistance decreases. Insulation resistance decreases. This is the insulation resistance of the underground cable. So with this, I end the first part of the underground cable chapter. From the next day, or rather from the next class, we shall start the new topics, more topics of the underground cables. Thank you.